Our first task is to graph points on, these points will be r theta, no longer xy. These are polar coordinates, and we're going to do them on the polar plane. So what does a polar plane look like? Well, we've got a pole right in the middle, and looks like a bullseye. 1, 2, 3. I could keep going. I'm just going to keep it at 1, 2, and 3. So I could ask you to graph a point like r theta equals directed distance 2 at an angle of pi over 2. Directed distance is 2. Well, this circle has points that are all a directed distance of 2 away from the pole, and they have infinitely many angles. We are interested in the one that is at pi over 2. When our angle is pi over 2 and our directed distance is 2, we have this, 2 comma pi over 2. Let's try another one. If I tell you graph r theta and I say it's at 3 comma negative 3 pi over 4, I know it's going to be somewhere on this ring because all of the points on this ring are a directed distance of 3 away from the pole. Negative 3 pi over 4 means we're going to go clockwise. Well, here would be negative 4 pi over 4, 4 negative pi. I'm going to go almost all the way there, but back it up 1 pi over 4. And here will be my point, 3 comma negative 3 pi over 4. I could give you r theta equals 1 comma 2 pi over 3. I'm going to be at a directed distance of 1 at a directed angle of 2 pi over 3. Well, here is pi over 2. Here is pi. Now, if I'm going in the counterclockwise direction, our angle is positive. So 2 pi over 3 is about right there. Because now pi over here becomes, we could change this to positive 3 pi over 3. So I'm going to go almost all the way over to 3 pi over 3, but back it up 1 pi over 3. So here is 1 comma 2 pi over 3. I don't have to stick with this simple 0 to 2 pi. I'm not restricted to that at this point. I could say r theta equals 3 comma negative 13 pi over 6. Well, here it's going to be somewhere on this outer ring here, and negative 13 pi over 6 means our angle is going to be clockwise. Here is 2 pi, or negative 12 pi over 6. I should say negative 2 pi. If I do 1 more pi over 6, here is our point, 3 comma negative 13 pi over 6. Note, that's the same as 3 comma negative pi over 6. These are coterminal. I just subtracted 2 pi, which is the same as 3 comma positive 11 pi over 6. All of these, or I should say each of these angles, put us down in the fourth quadrant there. I tend to draw little arrows to my point. You'll see that in your book, Ron Larson likes to run the point straight through. Either way is acceptable. Things just got a little bit more complicated, that's all. Here we've got a problem. Graph the point 4 comma 5 pi over 4. That's in polar form. R and theta are given directed distance, directed angle. Well, we're 4 away from the pole, which is this 0, 0. We've got the theta equals pi over 2 axis and the polar axis here. So 5 pi over 4 is going to be down here in quadrant 3, and it's a distance of a 1, a 2, a 3, a 4. So here's my best estimate here, and I can say, here is my point 5 comma, it's 4 comma 5 pi over 4. Directed distance 4, 5 pi over 4. There's the point. Now, the first one is pretty easy. We graph the point. Instead of going 5 pi over 4, I can find the coterminal angle. Remember, we did that early in the year. We just subtract 2 pi from it. Well, if this is 4 pi over 4, if I'm coming from this side, that's negative 4 pi over 4. So I'm going to come almost to negative 4 pi over 4, but I'm going to back it up 1 pi over 4. So my angle here is negative 3 pi over 4 with the directed distance of 4. So we've got 2 out of the 4. 4 comma 5 pi over 4 and 4 comma negative 3 pi over 4. To get the other 2, we have to hit the pause button and remember something about vectors. Ah, vectors. We miss you, vectors. We love you, vectors. Let's talk about vector v. If this is vector v, oh, we loved it, right? There she is, vector v, beautiful. It's a directed line segment. If that's vector v, we said this one here is the opposite of v. You know what I loved about vectors? I could click on them and drag them. Why don't I drag both of these vectors into standard position, which means I'm going to tie the little tails to the origin. Oh, the pole now. So if I have my axes, click, drag, here is vector v. Click, drag, here is vector negative v. They are in the opposite direction. Now keep this in mind. When we're graphing on the polar axis, we're not graphing vectors, but we can use this idea of vectors to help us graph what we were doing before. Vector v, the opposite of vector v, is the vector v, but flipped or reflected over the origin. Oops, over the pole now. So here we are back with this problem. I've got 2 that came fairly easy. Now, let's consider this. Now, this is going to seem a little crazy at first, but it will hopefully make sense a little later. I'm going to consider this here. This is a directed distance of a 1, a 2, a 3, a 4. It's 4 away, and its angle is pi over 4. Notice the difference between 5 pi over 4 and pi over 4. Well, it's a straight line. All I did is I subtracted 1 pi. That's definitely in quadrant 1. A directed distance of 4, a directed angle of pi over 4. Quadrant 1, quadrant 1, quadrant 1. We're all in agreement. It's quadrant 1. Now watch what I'm going to do. I'm going to take the opposite of the directed distance, which means I'm going to flip it right over the pole. So I can consider this point negative 4 comma pi over 4. What? Every cell in your body is probably screaming that negative 4 pi over 4 should be in quadrant 1. Ah, no. Positive 4 pi over 4 is in quadrant 1. When we take the opposite of the directed distance, we're essentially flipping it over the pole or adding 180 degrees or pi radians to our angle here. Well, what's another way to label this point? Instead of doing positive pi over 4, I could consider this almost all the way to negative 8 pi over 4, but back it up 1 pi over 4, and we can call this 4 comma negative 7 pi over 4. Well, 4 comma negative 7 pi over 4, if I took a bucket of ice water and threw it in your face at 2 in the morning, you would tell me that's in quadrant 1. It is. It's quadrant 1. Now, let's take the opposite of the directed distance. If I do that, that's going to flip us over the pole, and it's going to give us another option here will be negative 4 comma negative 7 pi over 4. And that's my little trick. These play with my head so much, I can waste days thinking, which quadrant are these in? I always graph the positive directed distance, and then I flip it over, and if I'm embarrassed about having to use my training wheels, I can even erase this and say, no, I just got this naturally without having to do this. I'm not embarrassed by this, by the way, but there they are. 4 comma 5 pi over 4, that's r theta. 4 comma negative 3 pi over 4, r theta. Here are the tough ones. Negative 4 comma pi over 4. I took this point, which was positive r, and I reflected it over the pole. And then here is negative 4 comma negative 7 pi over 4. Of course, this one is positive 4. negative 7 pi over 4. Here's a little bit of a training on this. Graph negative 3, 7 pi over 6. Here's my trick. I'm going to first graph positive 3, 7 pi over 6, and then I'm going to flip it over the pole. So I know here is 6 pi over 6. I'm going to go one more pi over 6 at a directed distance of 3. Here is 3 comma 7 pi over 6. I hope we can all agree that 3, 7 pi over 6 is definitely in quadrant 3. But we didn't want that, did we? Now that you've established this, let's take the opposite. Think about those vectors we talked about, and we're going to flip it over the pole. So here is the point, negative 3 comma 7 pi over 6. And if you're embarrassed by having to use these training wheels, I certainly am not, but you could always erase this and say, yeah, I got it straight away. It is quadrant 1. Now, it will mess with your head. You can look at this all day and think, is it quadrant 1 or quadrant 3 or what? Well, graph the positive one and flip it. That's my advice. Again, we're asked to graph negative 2, negative pi over 6. First thing I'm going to do, I'm going to graph positive 2, negative pi over 6. I change the directed distance to positive. I keep the angle negative. I don't care. That just means clockwise. Here we have negative pi over 6 and a distance of 2. And so hopefully we can all agree that this point is a directed distance of 2 at a directed angle of pi over 6. Now I'm thinking about those vectors. An opposite vector would flip us over the pole. And this would be the point, negative 2, negative pi over 6. And if I was embarrassed by my training wheels here, I could erase that and erase this. I certainly am not embarrassed by that, but just to make it a little more clear, note, if you look at this all day, it can screw you up. So always graph the positive one and then flip it, and you'll never get it wrong.